7-1. Specifically, we are going to be adding and subtracting polynomials. The closest analogy I can make for this is that you are adding apples and oranges, which we shouldn't, because apples are apples and oranges are oranges. So as you go through and add and subtract things, make sure that they're alike. A couple reminders before we jump into a bunch of terminology here. Don't forget that subtracting a negative is the same as adding a positive. So this is the same as 7 plus 8. And sometimes we forget that in the middle of a subtraction problem. Secondly, when I add two things that are alike, like 1x and 2x, don't forget the x has a 1 in front of it. So this is 3 x's. 3 times x, that's what that means. Next reminder is more about the next unit, and so I'm just kind of previewing that here. But when we multiply, we can multiply things that are unlike each other. That's completely doable. You can't add them, but you can multiply. You just have to take the 3 times the 2, so that gives me a 6. And then I take the x times the x squared. Again, don't forget there's a 1 hiding in front after that x as an exponent, so we add those exponents up and get 3. So again, reminder, just notice the difference between adding and subtracting, or multiplying. Okay, here we go. Some important goals to keep in mind. You are going to describe polynomials by their degree and the number of terms. What does a degree mean? The degree means you're looking at the exponent. In fact, we're looking at the highest exponent in the problem. And then the number of terms, the number of things that you're adding up or subtracting up in the problem. So how many items are there in your polynomial? Again, the other goal is that you know how to add and subtract polynomials. So first of all, vocabulary. What is a polynomial? A polynomial is 2 or more terms. So let me describe some polynomials to you over here. There is what we would call a monomial. Monomial means one thing. So for example, 6x cubed in the last problem right above that is a monomial. And so is 15. These are both monomials because it's just one thing. Notice there's no addition or subtraction going on in that problem. Binomial. This means there are two things. So for example, if I have 6x cubed plus 15, right? Or 3 minus x. Those are two binomials. Again, notice we have two things. 1, 2, 1, 2. So you can guess that a trinomial is now 3 things. So for example, 6x cubed plus x minus 15 is a trinomial because you can see there's 3 things that we're adding and subtracting. All right, next up is terms. Terms are the simple expression. There's no plus or a minus in front of that. All right, so for example, in the last problem that we just did, there are 3 terms. So that's why we call those kind of like 3 things that we're adding up or subtracting. Okay, whereas the binomial has 2 terms. So it's just a simple expression, no plus or minus in it. Degree. This is the highest exponent in the polynomial. So an example, if you only have a number like negative 15, that's called a constant. Notice there's no variable, right? Or the number 8, right? That's a constant. Now, if you have a linear expression, that means you've got a variable, so like negative 15x plus 8. Why is it linear? Because my highest power is 1. So the degree of that problem is 1. So the degree is 1. Now, if you are a quadratic, quad usually means 4, but in this case, because of language issues, it actually means 2. There's 2 dimensions to a square, to a quadrilateral. So for example, 15x squared plus 8x minus 3. There is now a quadratic because it's got a power of 2, is the highest. And as you might guess, the next one would be a degree of 3. So 15x cubed. Now that's all I need. I can say plus 4, doesn't really matter. This here makes that expression cubic. Doesn't really matter how many terms there are in the problem, just what is the degree, the highest degree. So finally, before we jump into some problems, they're going to ask for what is the leading coefficient? A leading coefficient is the multiplier of the term with the highest exponent, which we call with the degree. So in this last problem here, 15 would be my leading coefficient. 15 would be my leading coefficient here. Negative 15 would be my leading coefficient there. My leading coefficient would be 6. All right? It's whatever you're multiplying in the expression that has the highest exponent. So find the degree of each problem and what is the leading coefficient. So the degree is 2. The leading coefficient is 5. The leading, the degree looks like it's 3. Be careful, there's also a 1 there. So we take those 2 and add them up because this is just one term. So what is 3 plus 1? 4. The leading coefficient, as you might have guessed, is 8, is negative 1/2. Now this next problem has 2 terms. Notice there's an 8m squared and an n cubed. Again, the degree always comes from the highest one. So the degree is 3. Don't add the 2. That's a different term. Leading coefficient, again, comes from here. What number are we multiplying by? There's a silent, hidden 1. On this last problem, the degree is 0 because it's a constant term. There is no variable. And the leading coefficient, DNA, does not exist. Because you could say it's negative 3, but in this case, we don't even speak of a leading coefficient because there is no variable. Example 2. Write this polynomial in standard form. What is the degree? What is the leading coefficient? So to write it in standard form means that the degree has to be written first. So the degree in this case is the x cubed. Don't forget there's a negative there. The next most important term is the 15x because it's got a variable in it. And then the least important term is the 3. So the degree is 3, and the leading coefficient is negative 1. Okay. Again, we get all that from this first piece, this first term. Now, the last 2 examples that we need to do here are just practicing how do we add polynomials, how do I subtract polynomials. Adding is easier. Remember, it's apples to apples and oranges to oranges. So look at your polynomial and your second polynomial and ask yourself, are there any that have a common exponent? Start with your highest. So for example, I see a power of 3 and a power of 3. So on my scratch work area, I'm going to say 2x cubed plus x cubed. So if I'm adding those 2 up, we get 3x cubed. So there's my first term. All right, now I look at my powers of 2. I have 2 of them. So I have a negative 5x squared don't forget the negative, plus a 2x squared. So that gives me a negative 3. I'm always going to write plus, yeah, negative 3. You could write minus 3x squared. I think it's just a little more dangerous and less clear. Now the x has nothing in common on the other polynomial, so I'm just going to say plus x. And the 1 has nothing in common, so it doesn't combine. So here is my answer, written in standard form. One more example. I'll do this one a little bit faster. So 3x squared and x squared. I add those up. We get 4x squared. Next, I see an x and a 4x. So that's going to give me 5x's. And then a negative 6 and a positive 10 gives me 4. So there is my sum of those two polynomials. Subtracting, a little bit challenging because we now have a polynomial minus a polynomial. So the first thing we have to realize is that minus sign is going to affect everything after it. The best way to think about this then is that we are subtracting all three of those things. What that means is I'm going to change this to a plus, and then I'm going to change the sign of everything after it. So the negative 2n squared becomes positive 2n. The positive 2n becomes negative 2n, and the minus 4 becomes a plus 4. So now I just collect my like terms. Again, I've got a 4n squared and a 2n squared. If we add those up, I get a 6n squared. Okay? That's gone. I now have a 2n. Looks like that's the only n term. So I have a negative 2n. And then we have a 5 plus a 4, which is a 9. There's my trinomial with degree 2. So this is a quadratic trinomial. Quadratic because, again, degree 2. Trinomial because there's 3 terms. Example B, same thing. I'm going to subtract. So let's start by looking at the minus sign and distribute that minus sign so that this becomes an easier problem to do. Again, change the sign of everything. Now we start looking for things that are common. So we see a 4x squared and a 3x squared. I add those up, I get a 1x squared. Don't need the 1, but that's okay. Negative 3x and an x gives me a negative 2. And I'm going to change that to plus. You could write minus, but plus negative 2 I think is clearer. And then plus 13. There we go. Hopefully that makes sense. Good luck as you do these problems in 7-1 practice and show them to me. Thank you very much.